Hi, hello, namaskara. Welcome back to Diksha Karnataka once again. We have been doing this mock test series since quite some time, and already we have finished the first mock test and the part one of the second mock test. So, as you can see, we are here with part two, again, resuming from question number 151 to 180. I hope all of you liked the previous video in which we had done the first part. Definitely, I like to know all the feedback in the comment section. Please let me know. Let's have a very productive discussion in the comment section, and also if you have liked it, press the like button definitely. And also, there are a lot of students out there who are in dire need of such content, so please share this video with everybody. And for more content from our side, don't forget to subscribe to our channel. Also, all these papers are readily available in our WhatsApp channel, so I urge all of you to go to the description box, find our link and join the WhatsApp channel. Okay, so all the updates are put up over there. You can have live updates in the WhatsApp channel. And also, for those people who want to be away from the distractions of the social media, you can register into a portal which is also given. The link is given in the description box. Please go to the portal, register yourself, and you can get the question papers of these mock tests mailed to your personal email IDs. So from there you can download, and without all the social media's distraction, you can attempt the paper. And here we are to discuss the solutions of it. So once again, analysis and solutions of the physics portion. Let's begin with the question number 151, shall we? So this is a question based on the electromagnetic induction. A coil of resistance 10 ohm. The induced current developed by changing magnetic flux through it is shown in the figure as a function of time. The magnitude of change in the flux is. So first of all, there are several things that you have to note here. First of all, the resistance of the wire is given. Okay, resistance of the wire, which is a very important quantity which we might, or we will, okay, to be precise, need in this particular calculation. And this is a very strange thing that they have given a graph where I is the y-axis and time is the x-axis. Okay, so of course definitely current is varying. With that you can find the EMF and flux, but let's try to get it done very quickly in a very short method. Okay, so I hope all of you know the formula of induced charge. So you know the formula for induced EMF, induced current. What is the formula for induced charge? So the induced charge formula is given as, is a very important formula which most of you take it for granted. Okay, I'm pretty sure most of you might not be aware of this. Induced charge formula is given as change in the flux whole divided by resistance. This is a very important formula. If you didn't know, please make a note of it. Okay, so now what are the things that are given here? So resistance is given and we have to find change in flux, right? So we have to find the change in flux. This is the question, and resistance is given. Now what about the induced charge? How do you find induced charge? That is where this picture, this image comes into kind of limelight. So how do you find charge from this? It's very simple. Charge actually is the area under this current time graph. Charge is equal to area under. So area is half into base is 0.1 into height is 4. So we have induced charge as 0.2 coulomb. Okay, simple, right? So we have got the induced charge and we already have the resistance value. So just substitute it over here. So we have delta phi is equal to charge into resistance, which is 0.2 into 10, which is 2. So the correct answer here is 2 Webers. The change in the flux is 2 Webers, option B. Alright, so this question can be characterized as a very simple kind of a question if you know this formula. So if you know this formula and if you know how to crack this from the graph, how to obtain the induced charge, then it's a very simple question. If you hadn't known this question, these two major points, yes, then it becomes slightly moderate level or even a difficult level question. So please, all these chapters which I have repeated even in the previous video, that is electrostatics, current electricity, magnetism and EMI AC. So these four are, especially first three chapters, are very, very important, and you can include this also. So almost half of your CET paper is done. Okay, so around 25 to 28 questions are covered by these four chapters. So it's a very, very important set, the part 1 of your NCERT textbook. So please have a heavy focus on all that. This is a moderate level question if you hadn't practiced a lot. So this enables you to know that how much is your practice level. All right, fine. Anyway, let us look at the next question. The next question is, two coils have a mutual inductance 0.005. The current changes in the first coil according to the equation. So we have current, varying current, okay, alternating current, which is varying according to time, where I naught maximum current is 10 and omega is 100. So let me write this current in kind of an alternating current formula. So we have I naught is 10. So 10 into sine 100 pi t. So this is your current. This is the alternating current which is given. Okay, this is the proper format in which it has to be written. Now, what is the maximum EMF induced in the second coil? EMF induced, all of you know, EMF induced is nothing but M. Okay, so you want only the magnitude part, not the Lenz's formula. Let's not consider over here for time being. Di by dt. So obviously you have to differentiate this. So when you differentiate, when I is equal to this, so in this case di by dt is evidently I omega cos omega t. Okay, in this particular condition di by dt is I omega cos omega t. But when we are going to find out the E max, we only need M, okay, and in the di by dt we only need I omega. We don't need the cos omega t because we are finding the maximum. We are assuming cos portion to be 1. So I omega. Now substitute all the values. So M, we have it as mutual inductance is 0.005 into I is given as 10, I naught is 10, okay, into omega. So omega is given as 100 pi. So when you multiply all of this, 100 into 10 is 1000, 1000 into 0.005 is 5. The final answer is once again option B, 5 pi. So this is a very simple question once again, because you just need to know the induced EMF formula for a mutual inductance case, and also when you have a current in the form of an alternating current. So current is given as the alternating current format already, which is mentioned over here. Okay, so there's a combination of both electromagnetic induction chapter and the AC chapter. So if you're thorough with both the chapters, definitely this is an easy question. This is a cakewalk literally. All right, fine. Now let me give you another update on the Lakshya KCET crash course, which has been designed for those people who are looking out for best ranks, to score best ranks and to get into most privileged colleges in the state. So this is a course with a duration of 28 days for those who are looking for the final stage brush up. So you just need that last moment push into that privileged zone of scoring the best scores and best ranks and getting into the best colleges. So please consider this as a golden opportunity that we are trying to help you with this. Once again, all the details regarding this is given in the WhatsApp channel. So I urge all of you to right away go and join the channel now. All right, fine. So let us look at the next question. A coil has resistance 30 ohms and inductive reactance 20 ohm at 50 hertz frequency. If an AC source of 200 volt 100 hertz is connected across the coil, the current in the coil would be. So they're asking what is the current in the coil. First of all, there is a resistance and there is an inductive reactance. So this is an RL circuit. Okay, so you have to identify the circuit first. In any AC circuit, identify the circuit. It's an RL circuit. Now the thing is, so there is a reactance at 50 hertz. So at 50 hertz, we have a inductive reactance of, that is inductive reactance is given as XL of how much is it? 20 ohms. Now it is logical. Inductive reactance, capacitive reactance are heavily dependent on the frequency. So as the frequency changes, the reactance also changes. So obviously when the next case, when the frequency is doubled, the inductive reactance is also, inductive reactance directly dependent on the angular frequency. So when this doubles, this also doubles into 40 ohms. Okay, no doubt on that. Okay, inductive reactance is also doubled into 40 ohms because inductive reactance is directly proportional to omega or frequency. So when frequency doubles, inductive reactance also doubles. All right, so since this is clear, Now ultimately what do you want? Current. So the current is given as, once again, in such questions, in the AC questions, let me give you a tip, students. If they are generally mentioning current and voltage as it is, okay, like they have given a fixed value, or they are asking generally current or voltage, they are implying at the RMS value. Okay, this is a very important point. Most of you might get confused when they are generally mentioning current or voltage without any prefixes like maximum or RMS or alternating anything, then they are by default meaning RMS value. So we want the RMS current, which is nothing but the RMS voltage divided by the impedance. So voltage is given here, that is 200 divided by impedance, formula is R square plus XL square. So you can substitute all the values, 200 divided by root over resistance is 30 square plus 40 square. So 30 square plus 40 square, all of you know. So it is approximately coming at 50 square. Okay, so that is 50. So 200 divided by 50, which is easily 4 ampere. So the correct answer over here is option A, right? Very simple question. So the correct answer over here is 200 by 50, 4 amperes. All right. Yes. So this once again is a very simple concept, very simple question to answer. But yeah, you have to have the proper conceptual knowledge. So if you are kind of getting confused what happens when the frequency changes, then it will be difficult. So you have to know that when the frequency changes, inductive reactance also changes. And how does it change? It's directly proportional. It changes linearly. Okay. Then find the impedance, apply the voltage value, and there you get the answer. All right. It's very simple, right? Yes. Looking at the next question. In an AC circuit, the voltage is applied, E is equal to E naught sin omega t. The resulting current in the circuit is I naught sin omega t minus pi by 2. The power consumption in the circuit is. Now, it's very important to study all the circuits possible: purely resistive, purely inductive, purely capacitive, and the LCR series circuit. So these 4 circuits are highly important. So if you are thorough with the 4 circuits, this you can very well, like you can get it from the question itself, from the statement. The current is lagging behind the voltage. Voltage is already at omega t. Current is lagging behind the voltage by pi by 2. So which circuit is this? This is absolutely a purely inductive circuit. This is a purely inductive circuit. Okay, means according to the curriculum that we have already consumed, we have learnt. So which circuit is that where the current lags behind the voltage by pi by 2? It is purely inductive circuit. And in purely inductive circuit, what is the average power consumption? That we all know. It is absolutely 0. Okay. So if you have such kind of ideas which you had gained by already solving a lot of problem by continuous revision, then it becomes an easy job. Otherwise, you might mostly struggle. You might think that there are other ways of doing it. You might try, but the solution is as simple as this. Okay. So how much is the phase difference? And that is also another way. Okay, this is one method. Another method is, see, what is the phase difference? Both the places. It is pi by 2, right? The phase difference is pi by 2. So when you apply in the power factor, what is power factor? Cos of the phase difference. So the power factor becomes cos pi by 2, okay, which is equal to 0. This is another way of finding it out, but you don't have to even work out this much. If you have the proper idea where the current is lagging behind the voltage by pi by 2, it's an inductive circuit, the power consumption is 0. So if you have that idea, you can quickly jump into the answer. You can save a lot of time, which can be utilized for such calculation heavy questions like that. All right. So this is the very simplistic approach. You can have it. All right. Once again, if you have any doubt, you have any contradictions, anywhere you are stumbling upon, please let me know in the comment section. All right. So that we can have an elaborate discussion on that sometime later, or even in the comment section itself. Okay. So I really encourage all of you to have a very good productive discussion in the comment section itself. Please let me know if you have anything that additional you want to add on to it. You have any new methods of solving it. Let's know all that. Okay, fine. So next question. An AC voltage is applied to a resistance R and an inductor L in series. Once again, we have an RL circuit. Okay, resistance R, L. If R and inductive reactance are both equal, it was a very important point that is given in the question, resistance and the inductive reactance are equal, then what is the phase angle? What is the phase difference between applied voltage and current? It's a very simple question. Phase angle can be found out in several ways. First of all, where and all the phase angle appears? First of all, tan phi. Okay, we all know that particular relation of tan phi is equal to XL minus XC mod by R. Okay, whichever is greater, you can apply that. And cos phi also comes into the picture, where it is R by Z. Okay, so all this we already know. Okay, so you can use either of them, any one is okay. Okay, and ultimately here what you get is XE is not present. Okay, XE is not present, XE is absent. So tan phi can be written as XL by R. Since they both are equal, it is 1. Okay, since they both are equal, it's equal to 1. So where tan phi is equal to 1, what is the phi value? Phi value is absolutely pi by 4. Okay, pi by 4. So the correct answer is option B. Option B is the correct answer. Once again, very simple question. If you have the knowledge of phase angle and how to determine phase angle with the given conditions, this is the correct method to do it. Alright, very simple question. Let's look at the next question. Next question is the electromagnetic waves. It's a very simple question. It travels in the free space with the speed of light. That's all. Simple. Electromagnetic waves are just a kind of an elaborate understanding of light itself. Okay, electromagnetic waves theory was postulated by the great scientist Maxwell. Okay, so James Clerk Maxwell, not the R.C. Beamwala Maxwell. All right, so he had said that the light has a perception of electromagnetic waves. That means that electromagnetic waves travel in the free space with the speed of light. Okay, none of the other is correct. Speed of sound is wrong. With the same speed in all media, that's wrong. Okay, do not travel through a medium, so that's all wrong. We can negate all that, and ultimately we will get at option C. Very simple question. Now, a ray of light passes through an equilateral prism such that angle of incidence is equal to angle of emergence. See, when such clue is given right in front of you, it must be glaring for you. That must be the level of practice. Whenever you come across such even small clues, you must be able to travel, okay, in your mind to that particular concept. Angle of incidence equals angle of emergence. This is a prime condition for minimum deviation. Alright, when does the deviation takes a minimum value? When the angle of incidence is equal to angle of emergence. So it's a minimum deviation. So minimum deviation formula you can apply, delta min is equal to 2i minus a. Alright, so these all formulas also must be, at the tip of your fingertips, right? So only then this will be easy, otherwise it's gonna be slightly difficult to solve. So now we have the basics. Now let us see the further clues given in the question. The latter is equal to 3/4. That is, latter is emergence, or even since emergence and incidence are both same, so both are equal to 3/4 of the angle of the prism. 3/4 of A. Okay, so now substitute this here so that you can find the answer. So delta min, or whatever is the deviation angle, is equal to 2 into 3/4 of A minus A. Okay, so A you can take it as common. Okay, then you have 3/2 minus 1 is equal to 1/2 A/2. Delta min is equal to A/2. A is equal to equilateral triangle. A is equal to 60. That means my deviation angle is 60/2, 30 degrees. Correct? Yes. So the correct answer is option B, 30 degree. Very simple question. Very, very simple question. So you just have to be thorough with the prisms concept. You can definitely crack this. As I mentioned to you, whenever you get a clue in the question, just transport yourself to that particular concept immediately so that you can connect the next whatever clue is given. Like angle of incidence is equal to angle of emergence. That means I is equal to E. We are talking about minimum deviation condition. So the corresponding formula, and then we can take the clue and proceed ahead. All right, very simple question. Next question. Okay, So question number 158, the magnifying power of a telescope is 9. When it is adjusted for the parallel rays, the distance between the objective lens and eyepiece is 20. The focal length of the lens are. So first of all these are in words. You have to convert it into mathematical expressions. Okay. So the magnifying power of a telescope is 9. How do you find the magnifying power of telescope? FO by FE. Okay. This is the first given clue. The magnifying power of a telescope is the ratio of objective length focal length, objective lens focal length, and eyepiece focal length. Okay. Now, the distance between the objective and eyepiece. What is the distance between objective and the eyepiece? That is the length of the telescope. Length of the telescope is given by FO plus FE, which is equal to 20. Now you can very well compare these both equations 1 and 2. Okay, so you can do any method to solve them. Okay, you can cross multiply and you can substitute, and solving 1 and 2 you can do it on your own. Okay, solving 1 and 2, okay, sorry, 1 and 2, you will get ultimately objective length focal length is 18 centimeter and eyepiece is equal to 2 centimeter. Simple. All right, so it satisfies both the equations, correct? It satisfies both the equations, and the answer is yes, option C is the correct answer. Very simple question, just that you have to be thorough with the telescope concept, and then you can easily do it. Whenever it is given in words, you need to translate it into the relevant mathematical equation. If you do that, your 3/4 job is done. Actually, when you took both these equations, your job is done. Now it's just mathematical simplification. There isn't any physics after you have got these two equations. Okay, so there is physics only until you get these two equations. After that, it's just mathematics. You just solve them and you get the answer. All right, fine. Once again, a very easy question. Yes, identify the wrong sign convention. It's a very simple question. Just go through this all the four options, very quickly. You can take a pause as well. I can tell you right by looking at it. Yes, the correct answer over here is wrong sign convention is option D. Virtual image having a negative magnification. Virtual images are usually erect in nature. They will have a positive magnification. They will not have a negative. So the wrong sign convention is option D. Okay, very simple. You can go through the others also. You will find that they are all correct. Okay, they don't suit this answer. They are asking for wrong sign convention, not the right sign convention. These are all right. Okay, this is the wrong one. Fine. Next question. When a plane face of a plano convex lens is silvered, it behaves as a concave mirror of focal length 30. But when it is curved surface is silvered, it behaves as a concave mirror of focal length 10. The refractive index of the lens material is. Now this question requires certain extra knowledge of silvered lenses. Now there are two cases here. The first case is the plano convex lens, plane face is silvered. That is, you have a plano convex lens and this. So the focal length here is actually, say, given as radius of curvature 2 times refractive index minus 1, which is 30. Okay, which is already given, right? Now in the second case, okay, let me write F1. In the second case, the other side is silvered. That is, you have this curved side as silvered. So in this case, the focal length is given as R divided by 2n, which is 10. Okay. Now these two formulas are the formulas for silvered lenses. When you have lenses silvered like this, plane side silvered, this is the formula, and the curved side silvered, this is the formula. Okay, n is the refractive index. So this is slightly beyond the curriculum, okay, beyond the syllabus. Even NCERT does not include this. So I don't know how far this question is actually relevant for the examination, but since it is there in the mock test and you all would be kind of curious to see the solution, let me just tell you, these are the formulas. If you want to make a note, you can make a note. These are the formulas. When the plane side is silver, this is the formula. When the curved side is silver, this is the formula. Now you can divide both of them. Okay, so divide both the equations to find the correct answer. You want to find n, divide both of them. So RR will get cancelled. So you will have 2n by 2n minus 1 is equal to 30 by 10. So 0, 0 cancel, 2, 2 cancel, cross multiply. Ultimately, you will get n is equal to 1.5. Now I leave the calculation of this, detailed calculation to you. So please, you can go through it. If you find any contradiction, please let me know in the comment section. All right, this is the answer, and finally you can take option D. Okay, 1.5 is the correct answer. All right, this also is a very easy question, provided you know this formula. It's a very formula based question. Okay, there is nothing in this, just like the previous question, very much a formula based question. If you know the formula, it's very simple to do it. Okay, but as I have told you, as I gave you a disclaimer, this is something which is beyond the normal NCERT curriculum. So I don't know the relevance of this in the KCET examination, but let's, just to quench our thirst of curiosity, we had done this. Anyway, let's look at the next question. Huygens concept of secondary wave allows us to find the focal length, or is it a geometrical method to find the wave front? Is used to determine the velocity of light, is used to explain the polarization. If you have understood the Huygens principle, we all know what does Huygens principle say. Each point is a secondary disturbance. When those locuses are again plotted together, it forms a new wave. It's a geometrical method to find the wavefront. That's all. It's a geometrical method to find a wavefront. That is the correct understanding or perception of Huygens principle. Okay, Huygens concept of secondary wave. It's just a geometrical method to find a wavefront. That's it. All right. Very, very simple question. Now this, yes, it is kind of a difficult question. Means you have to understand what is happening here. The graph showing the dependence of the intensity of transmitted light on the angle between polarizer and analyzer. Polarization is actually kind of taken off from the PUC syllabus, and this time in the CET 2024, it's highly unlikely to repeat such questions, but still, once again, since it is present in the mock test, let's have an understanding. So what does happen when there is an angle between the polarizer and analyzer? So when the polarizer and analyzer are actually parallel to each other, light will pass through. Okay, the light will actually pass through very easily. Okay, maximum transmittance. But now when you rotate one of them, okay, or they rotate mutually such that now they are perpendicular to each other, the light waves get blocked and there is no light transmitted. So at 90 degree exactly, you won't have any light coming through. Intensity will be 0. Once again, you rotate mutually or one of them and you get 180 degree. Okay, that is once again they are parallel. Okay, anti-parallel, whatever. Then again the light can pass through. Okay, it's like two frills like this, fingers. Okay, so when they are like this, light pass through. But when they are actually perpendicular, there is a blockage of light. Now, which of the graph suits to this explanation maximum? Okay, that is option B. Okay, where it becomes minimum at 90 degree. Okay, it becomes minimum at 90 degree, and at 180 and 0 it reaches the maximum once again. All right, so this is the correct answer. Once again, the relevance of this question in the upcoming KCET is questionable, but still, okay, you can have a brief understanding. All right, next question, 163. A cathode ray consists of, all of you know, cathode ray tube experiment. So this was conducted so as to determine a kind of, it's not to determine anything, but still ultimately we ended up determining a small negative charge. That charge is called electron. So the cathode ray actually consists of a beam of electrons. Okay, beam of electrons. It's a lot of electrons passing in a same direction. Okay, that is cathode ray. Very simple question. 164, photoelectric emission is observed from a metallic surface for frequency mu1 and mu2, and the incident light rays mu1 is greater than mu2. All right, if the maximum values of the kinetic energy of the photoelectrons emitted in the two cases are the ratio 1:k, then the threshold frequency is, okay, a huge question. You have to understand one by one. So there are two particular frequencies, and at each frequency you are getting two different kinetic energy. Okay, so let's write the Einstein's equation for both the case. First case, h nu1 is equal to h nu naught plus k1. Okay, this is the first condition, right? So let me rearrange, bring the nu naught to this side. So I will have h nu1 minus nu naught is equal to k1. Let me have this as my first equation. Second equation, the second case. Okay, second case also I can write similarly. Okay, let me not write like this. Directly I'll go. Second case is nu2 minus nu naught is equal to k2. Simple. Okay. Now let's take a ratio. So when we take a ratio, what happens? Nu1 minus nu naught whole divided by nu2 minus nu naught is equal to k1 by k2. Alright, k1 by k2, correct? Yes. But what is K1 by K2? It's already given in the question. K1 by K2 is given as 1 by K. Okay, K1 by K2 is 1 by K. This is K1 by K2. So you can, in place of K1 by K2, you can write 1 by K. So you will have a nu1 minus nu naught whole divided by nu2 minus nu naught is equal to 1 by K. Okay, just cross multiply and have a solution. Okay, just cross multiply, and when you do this, so you will have nu K1 minus K naught. So nu K naught will get cancelled on both the sides. Okay, so nu naught we can take a naught somehow, nu naught we can remove, and ultimately you will have the answer as like this. So nu K1 minus K2 divided by K minus 1. Okay, so the correct answer here is B. So you can check it yourself. Okay, you can eliminate mu naught somehow. So cross multiplying, and you will get the final answer as nu K1. So they are asking the threshold frequency. Yes, ultimately you have to find the nu naught. So solve for nu naught, and nu naught is equal to, yes, K nu1 minus nu2 whole divided by K minus 1. All right. Yes. This is the correct answer. Now this, yeah, it's not an easy question. Why? Because you have to take two equations, and then mathematical simplification is what takes the huge toll over here. So having a kind of, when you have so many quantities, okay, you have to deal with so many quantities, 1, 2, 3 or more than that, and you have to simplify them. So it's pretty difficult, but I won't put extremely difficult. It's kind of a moderate level question. Okay, it's kind of a moderate level question. So, and it's pretty huge also. It might discourage a lot of you to kind of attempt it, because you might think that it assumes a lot of time. Just try to translate what is written into their corresponding mathematical equation. Definitely you will get it. Okay, fine. Let us look at the next question. Yes, Rutherford's atomic model was unstable because of, what is the reason of Rutherford's, failure of Rutherford's model? All of you know this. What happens over here is basically, see, nuclei will break down, electrons do not remain in orbit, orbiting electrons radiate energy, electrons are repelled by the nucleus. So first of all, option D is very glaring. Electrons are repelled by the nucleus. That's not pretty much possible. Even you think sensibly, electrons are negatively charged, nucleus is all the more a positively charged entity. That's not possible. Electrons do not remain in the orbit. No, that was not actually given by the Rutherford's model as it is. Nuclei will break down. No, nuclei never breaks down. That's not even what he meant. But basically the problem with Rutherford's model is the orbiting electrons radiate energy. Now Rutherford's model was heavily based on the classical principles of physics. So classical physics, where all this electrostatics and electricity, those kind of concepts were assumed, not the modern quantum nature of the subatomic particles. So therefore, because of that, there was a kind of a prediction that there will be radiated energy will be radiated because of the acceleration of electron in this circular path. Okay, circular path, centripetal force, there will be acceleration. Accelerating charge particle will emit radiation. So this definitely kind of kills the stability, understanding of stability of the atom. Therefore the correct answer, okay, atomic model was unstable. Instability is because of orbiting electrons radiating energy. All right, option C is the correct answer. Fine, very simple question. If you have the understanding of Rutherford's model, you can do this. Now let us look at the next question. Question number 166. So according to Bohr's model of hydrogen atom, so which of them is correct? So linear velocity is quantized, angular velocity is quantized, linear momentum is quantized, angular momentum is quantized. Second postulate exactly lets us know that the angular momentum is the one which is quantized, where L is equal to nh by 2 pi. Okay, so L is given as, yes, nh by 2 pi. That means with each orbit, the angular momentum is kind of keeps increasing with the principal quantum number. So the correct answer is option D. All right, very simple question, straightforward. So if you understand it, you can directly get it. Next, question number 167. As per Bohr's model, the minimum energy required to remove an electron from the ground state for doubly ionized lithium atom. So doubly ionized lithium atom means Li2 plus. So it's a hydrogen like atom. Definitely we can apply Bohr's model over here. Now at any time, you are being asked to remove an electron, ionization energy. So ionization energy of a particular level is the positive value of the energy level itself. So if you want to find the ionization energy from the first orbit itself, you have to remove the electron from the first orbit itself. So that energy is bound to the atom, it's negative. The ionization energy is positive of the same value. For example, lithium ion. Okay, what is its energy at the ground state? So the energy at the ground state is given as, generally for any hydrogen like atom, it is Z square by N square into minus 13.6 electron volt, correct? So here ground state N is equal to 1, Z is equal to 3. So 9 into minus 13.6, it is approximately minus 122.4 electron volt. This is the energy of the electron in the ground state of the lithium atom. So you need equal amount of energy to remove the electron, that is ionization energy at this level is equal to plus 122.4 electron volt. The correct answer is option D. Okay, so please keep this important tip in mind. Ionization energy to remove an electron from particular energy level is the positive value of the energy of the same level. Okay, whichever level it is, the positive value of the same level, that is the ionization energy. All right, once again, if you have that single tip in your mind, if you know that very clearly, then you can really answer this at a very quick time, right? Okay, next question. The radius of a nucleus is directly proportional to mass number, inversely proportional to atomic weight, directly proportional to cube root of mass number, none of this. Once again, a very simple question where the radius of the nucleus is directly proportional to cube root of the mass number. Option C is the correct answer. Very simple, straightforward question. Alright, next, nuclear force exists between neutron, neutron, proton, neutron, neutron, proton. Nuclear force exists between all the nucleons, whether it's neutron or proton. Okay, so whatever be the combination, it exists between all of them. So the correct answer is all of this. Right, once again, a very simple question. Now let us look at the next question. So question number 170, the mass of lithium, which has 7 nucleons and 3 protons, nucleus is 0.042 atomic unit less than the sum of the masses. So that means that this is the mass defect of lithium, 0.042 atomic mass. All right. The binding energy per nucleon of lithium nucleus is nearly. So binding energy per nucleon, first you have to find the binding energy. How do you find the binding energy? Binding energy is found using the formula mass defect into 931. All right. So 0.042 into 931. For time being, let's just assume it to be approximately 1000 times, that is 42 mega electron volt. Okay. So binding energy is somewhat close to 42 mega electron volt. But this is not the answer that we want. We want binding energy per nucleon. So that is binding energy per nucleon is given as binding energy whole divided by the mass number, which is 42 divided by mass number is 7. In case of lithium, A is equal to 7. So mass number is 7 divided, so it is equal to 6 mega electron volt per nucleon, right? So anyway, this is an overestimation. So 0.42 into 931 is somewhere close to 42, but slightly lesser. So the actual value is slightly lesser than 6, close to 6, slightly lesser. That is 5.6 mega electron volt. So the correct answer over here is 5.6 mega electron volt. This is a very important tip that I would like to give you, is that estimation. Okay, so the kind of skill of estimation. So you have to estimate the number to a closer value, at the same time keeping in mind whether it is lesser than the estimate or greater than the estimate. So likely at the end you can round off to the correct answer according to the given answer. All right, so this is the answer. Fine. So now let's move to the next question. Which of the junction diodes shown below are forward biased? When is a diode forward biased? This is a very important tip. All of you please make a note of this. When your P side, okay, is connected to a higher this thing. P side is connected to a higher potential compared to your N side. When your P side is connected to a higher potential compared to N side, that is when it is forward biased. Okay, when is it forward biased? When the P side is connected to a higher potential compared to the N side. Look at all of this. Earth means it's a zero potential. Okay, Earth means it's a zero potential. So 0 volt, 0 volt. So N side is connected to higher potential. This is not possible. Here also N side is connected to higher potential. 0 is greater than -10. 0 is greater than -5. Not possible. N side is connected to 10. P side is connected to 5. Again, N side is connected to higher potential. Not possible. So therefore, the correct answer is option A. -5 is connected to P side. -10 is connected to N side. Here exactly the potential at P is greater than the potential at N. So the correct answer over here is absolutely option A. Alright, this is how you understand. Please keep this tip in your mind. How do you identify whether a diode is connected in positive bias or forward bias or reverse biased? Look at the potentials that P and N are connected to. If P is connected to greater potential, it is forward bias. If N is connected to greater potential, it is reverse biased. Alright, so this tip will help you a lot in this kind of questions. There are questions where you have to calculate the potential current and all that. So please keep this in mind. Alright, fine. Next question. If the ratio of the concentration of electrons to that of the holes in the semiconductor is 7/5. So they have already given number of electrons to number of holes is 7/5. Okay, that is given. And also they have given something else, and the ratio of the currents, that is current because of electron and current because of holes, that ratio is given as 7/4. In that case, what is the ratio of their drift velocities? What is VE by VH? Now, lot of you might be kind of startled with this question in the beginning, but just get reminded of your current electricity chapter, that particular formula where I is given as NEAVD, drift velocity. Now apply this in this case. So current through the electron is equal to number of electrons, charge, area and drift velocity of electrons. Hole divided by current of holes is equal to number of holes, charge, area and VE. Here EA is constant, they will get cancelled. IE by IH is given as 7/4 and NE by NH is given as 7/5 into VE by VH. So it is essentially VE by VH is 5/4. That's it. Option C is the correct answer, 5/4. So this is how you do this. Okay, so you have to be very much, when such kind of questions are very unique, even though they are very important as well. So it is like you have a culmination of several chapters, several topics all together, right? So this is a semiconductor chapter, this question is primarily based on, but you have to bring in a concept from the current electricity chapter, okay, that particular formula. So if you hadn't remembered this, then this question would have been really very difficult, okay, not even moderate, very difficult. You wouldn't be able to make through. This is the gateway, okay. So if you would have known this, then definitely you could have applied all of this and then got the answer. All right. So such questions are very important. Please make a mark down such questions where multiple chapters, multiple concepts are culminated together to form a single question. All right. Next question. The reading of the ammeter of the silicon diode in the given circuit is. Now, I don't know how many of you remember this. Mostly this value will be given in the question. That is the barrier potential of silicon diode is 0.7 volt. Okay. Now this is something that you need to know. Okay, not memorize exactly. This will be given in the question, so no need to panic. All right. So if you know this, then everything ahead is smooth. So what are they asking? Current. Ammeter reading current is actually the net voltage. Okay, because battery is giving 3, but it is facing a barrier potential 0.7. divided by total resistance. So that is 3 minus 0.7. Barrier potential will try to negate the applied voltage, divided by 200 ohm. So this is 2.3 divided by 200, which is approximately 11.5 milliampere. All right. So you can cross check the calculation yourself. Okay. 2.3 divided by 200 is approximately 11.5 milliampere. So option C is the correct answer. Once again, if you have any contradiction with respect to the final answer, you can let me know in the comment section. Please do that. All right. So that we can have an elaborate discussion sometime later or whenever possible. Right. Nice. So all these questions have been very easy. I mean, like past several questions have been very easy. Let's see if there are any challenging questions ahead. Okay. Two straight conductors AOB and COD are perpendicular to each other. So you have a conductor AOB and then you have a conductor COD. Okay. So they are perpendicular to each other. They all carry the same current. I mean, not same current. This is I1, this is I2. Okay, two different currents. Now one thing, let me tell you, if the current direction is perpendicular, obviously you all know the right hand thumb rule. The magnetic field direction is also going to be perpendicular. Okay, magnetic field directions are also perpendicular. That means that the magnetic field due to B1 is going to be perpendicular to magnetic field due to B2. All right. The magnitude of the magnetic field at a point P at a distance from the point O. So from point P at some distance from O, some point P, what is the magnetic field? So first of all, you have two vectors. Magnetic fields are vector. So they are perpendicular to each other. So the net magnetic field is going to be root over B1 square plus B2 square. Now what is B1 and B2? So B1 is simply mu naught I1 divided by 2 pi r. So all of you know this, no doubt, right? 2 pi r or 2 pi a, distance is a, plus whole square plus mu naught I2 divided by 2 pi a whole square. So everything is under root, correct? Now it's a simple mathematical simplification, nothing. Okay. Now you can look at the options and you can directly find the answer. So mu naught by 2 pi a, mu naught by 2 pi a whole square is common. So when you pull it out, you will get mu naught by 2 pi a whole root I1 square plus I2 square. So the correct answer is option C. So what will be under root? I1 square plus I2 square will get stuck inside the root. Rest everything will come out. So the correct answer over here is option C. Okay, very simple. So you just need to have the understanding, right? Conceptual knowledge and understanding will definitely be able to make it. Currents are perpendicular, that means magnetic fields are also perpendicular, and similarly apply the value. All right. Yes, good. Let's look at the next question. Velocity of a particle at time t is given by v is equal to at plus b by t plus c, where a, b, c are constants. The dimensions of a, b and c are respectively. Now you see, there is a big dimensional rule that I need to tell you. Whenever a quantity is represented as a sum of two other quantities, sum or difference plus minus, all the quantities are having same dimension. For example, here v, at and b by t plus c, they are having same dimension. Okay, please keep it in mind. And there's a very important tip also, please make a note. So when you have three quantities, a is equal to b plus c, all of them have same dimensions. Only then you can write like this. They are supposed to have same dimensions. If you are writing three equations like this, three quantities like this, all of them are of same dimension. That means v, at and b by t plus c are having same dimension. Okay, are having same dimension. One second. Yes, even all these three are having same dimension. But then let me tell you an even easier way. Okay, so we all know that here you have two quantities added together. That is, let me write it in a slightly different color. Yes, t plus c. You can do it only when t and c are of same dimension. T is time. So what is the dimension of c? It is absolutely the dimension of t, time. Now which option has that? Can we use the elimination method? Which option has c having t? It's not this, not this, not this. Yes. So using the elimination method, you needn't even find the others. There is only one single option where C is having T as a dimension. Option D is the correct answer. This is a very important trick, elimination method. So you have to find multiple quantities. You can narrow it down. Okay, find the easiest one. Find the easiest one. Look at the option, which are all the options, or a single option which is having. If it's a single option like this, which is having that particular value, you are lucky enough. You don't have to find others. That itself is the correct answer. Go ahead. But if you have like 2 or 3 options, then you will have to find the others as well. See, the others are also very simple. Velocity and AT are having same dimensions, right? Let me use that color itself. Velocity and AT are having same dimensions. That means AT has the same dimension as velocity. A into T dimension is equal to velocity dimension LT minus 1. Okay, right? Now, bring the T down. So what happens? A is equal to LT minus 2. Correct? And similarly, B. So this is time, and this B by T plus E is having a velocity dimension. So what divided by T will give you velocity? That is length. Okay, so the correct answer is obviously option D. So this elimination method is very important. So you can just narrow it down and you can eliminate all the others. All right, fine, very good. Next question, let's see. A ball is dropped from a bridge at a height of 176.4 meters over the river. After 2 seconds, a second ball is thrown straight downwards. What should be the initial velocity of the second ball so that both hit the water simultaneously? Now two balls are dropped. One is dropped, free fall. The other one is thrown after 2 seconds. Okay. So, but both of them touch at the same time. So what is that velocity with which you should throw so that both of them touch at the same time? Now time is a very important quantity that you need to know in this. Okay, because there is a time variation, that is the biggest clue. So first case is a free fall. First ball is a free fall case. It is just dropped. So in case of free fall, the height is given by half gt square. Height is given by half gt square. Okay. So how do you do this? Like how do you find t in this? T is equal to 2h whole root by g. So which is 2 into h is 176.4. Okay. Hold on. 176.4 whole divided by 9.8. Okay. So this is approximately, T is approximately 6 seconds. So all of you can cross check this once again. Okay. So the time taken by the first ball, it is T seconds. For second ball, obviously we know second ball takes a time 2 seconds lesser than the first ball because it is thrown 2 seconds after that. The first ball takes 6 seconds. The second ball must take a value lesser than 2 units lesser than that. So it is 4 seconds and it is having an initial velocity. So you can use the formula h is equal to ut plus half gt square. Substitute all the values, that is 176.4 u into 4 plus a half 9.8 into 4 square. Okay, so you can solve this and find u ultimately. Ultimately the u is going to be, if you solve this correctly, approximately it's going to be 24.5 meter per second. Okay, so approximately this is going to be 24.5 meter per second. The correct answer is option D. All right. So this calculation you can do it yourself. You can check it once again whether you are getting the correct answer. If at all there is any contradiction, please let me know in the comment section. Once again, this motion topics where you have to use multiple motions and you have to culminate into one single question. So it is slightly tricky. These kind of questions are always somewhere lying between moderate and difficult. Okay, they are not very easy kind of questions. So please mark this question. These kind of questions are very important. I had made you mark in the previous videos as well. So please keep in mind of such questions. All right. Yes. The only key is practice. So practice as many questions as possible. Next question. If the relation between the range and time of flight is t, then the projectile is given as r is equal to 5t square. The value of angle of projection is. Now the relation between range and time of flight is given like this. Simple, you just have to expand into their formula. Okay, whatever given formula you know. Range formula, all of you know, it is u square into sine 2 theta divided by g. And the t formula is 2u sine theta whole divided by g. Okay, fine. So this is how you do it, correct? So the formula substitution must be precise, otherwise there are chances that you can make mistake. So first of all, u square and this u square will get cancelled. What is remaining? Sine 2 theta, I will write it as 2 sine theta cos theta divided by g. On the other side we have 5 into 2 square 4 into sine theta divided by g square. Okay, sine square theta divided by g square. So g square g goes, sine theta sine square theta goes, 2 and 4 goes. Okay, so we have essentially, let's come to this part. Okay, so we have cos theta is equal to 5 into 2, 10 into sine theta divided by 1, g is remaining here, so that is 10. So 10 cancels, tan theta is equal to 1, okay, which implies theta is equal to 45 degrees. The correct answer is option A. Yes. So this question proves how important it is to remember all the major formulas of projectile motion, that is time of flight, range and maximum height. So all these formulas are extremely crucial. So please remember all of them, otherwise in such kind of questions there will be a huge hiccup. Okay, so please don't bring it on. If you remember them, you can easily solve them, then it's just mathematical simplification. Ultimately you have to find the theta value, which is 45 degrees, right? So this is also easy if you know the formula, otherwise it's going to be moderately difficult. Next, a body of mass 10 kg is acted upon by two perpendicular forces 6 Newton and 8 Newton. The resultant acceleration of the body is. So now this question not complete, I would say. Okay, personally as a teacher, this needs a few more explanation. At least one diagram would have been correct. So actually the perception of this question is like this. So you have a body on the floor, okay, on the surface, and the two perpendicular forces are like this. 8 Newton is in this direction and 6 Newton is in this direction. So this diagram is important, otherwise you can assume any body anywhere and two perpendicular forces. Okay, so yes, you can do that, but that just complicates the issue. Okay, you will have multiple assumptions in that case, just reducing down things to this level. Okay, so this is the case, all right, and the resultant force definitely is going to be somewhere like this. Now how do you find resultant force? Resultant force is simple. Resultant force is root of 8 square plus 6 square, absolutely 10 Newton. Okay, and resultant acceleration, it is given as, resultant acceleration is given as resultant force by mass 10 by 10, 1 meter per second square. Okay, 1 meter per second square, that is the correct answer. All right. Yes, so the resultant acceleration is 1 meter per second square, that is known. Now we have to finalize the angle. Okay, so how do you find this angle theta? Okay, with the 8 Newton. So both the places where we have logged A and C, we have to find the angle with respect to 8 Newtons, correct? So here theta is with the 8 Newton. Now tan theta is given as opposite by base 6 by 8, 3 by 4. So theta is tan inverse of 3 by 4. Tan inverse 3 by 4. Absolutely the correct answer is option A. Option A is the correct answer, correct? Yes. So this is how you do this question. This question is slightly vague because it lacks a lot of information, a lot of depth, because it is just given as two mutually perpendicular forces acting on a body. Lot of assumptions can be generated. These questions need to be a little bit more precise, but given this situation, this is how you do this. Okay, so if that diagram was given, I really understand that this question is an easy question. This is not at all difficult question. If this diagram and more specifications were given, it's certainly an easy question. Okay, fine. The penultimate question, last but not the last one. Which one of the following statement is true? Okay, once again, it's a very simple statements. Simple statements are given, very easy to answer. momentum is conserved in elastic collisions but not in inelastic collisions. That's false. Momentum is conserved everywhere. Total kinetic energy is conserved in elastic collisions but momentum is not conserved in elastic collisions. That's also false. Total kinetic energy is not conserved but momentum is conserved in elastic collisions. That's absolutely correct. Okay, option C is the correct answer. Just to check. Option D, kinetic energy and momentum both are conserved in all types of collisions, is absolutely wrong. Okay, so inelastic collision, energy is not at all conserved. So the correct answer is option C. Very simple, straightforward question, right? No doubt about it. And the final question of the mock test paper, 180, question number. According to the principles of conservation of angular momentum, if momentum of inertia of a body is decreases, then its angular velocity. So it's a very logical question. What happens when the angular conserve in the like according to the principle, if the moment of inertia decreases, angular velocity. So what is the angular momentum formula? I omega, right? So suppose the angular momentum is conserved, it's constant, and the moment of inertia is decreasing, obviously the angular velocity must increase. It's a simple understanding. Okay, so L must be constant, I is decreasing, that means omega must increase. Okay, very simple question. This you can definitely crack it very easily. All right, I really hope most of you would have done this as well. All right, yes, so we have completed all the questions of the physics portion, right? So don't waste any time. Join Diksha KCET WhatsApp channel immediately for all the updates regarding the Abhyas KCET series as well as the Lakshya crash course. So all the papers are available in the WhatsApp channel. Quickly go into the description box and join the WhatsApp channel for all the updates. And also in the description box, there is a link given for those people who want to avoid all the distraction from the social media and get the PDF copy of the question paper right into your personal mail ID. So that's also given in the description box. Please venture all that. And if you have liked our video, so please press the like button. And also let me remind you students, all those people who are really in look for those prominent content which is relevant, which is very strong in the subject and which will really challenge them to prepare for this examination, are waiting for such content. So share this with all of them so that even they are benefited. And please don't forget to subscribe to our channel as soon as possible for further updates and press the bell icon so that you will have timely notifications of all the content that we release. So I hope you have liked today's video, and for further content, until the next time we meet, this is me Karthik signing off. Adios.